Hello everyone, it's Mr. Kaplan again, and I'm here to present the second lesson for Chapter 8 that deals with representing quadratic relations in different ways. So in the last chapter, we just did a quick introduction in terms of how we can look at a graph of a parabola, okay, which is the graph of a quadratic relation, and interpret what information is given to us based on the questions that were presented to us. And today's lesson, we're going to get a little bit technical here, and we're going to look at the different forms of the ways you can see quadratic relations. And basically what we're also going to see in this lesson here is how this chapter ties into the previous one. So I mentioned at the end of the last chapter that this particular chapter is a continuation of it. Well, you will see it, you will see that part in today's lesson. Now, what I also want you to have handy, and then I'll refer to it once we get to that portion of the lesson. Okay, have a cell phone ready or a camera, because there is a part that I'm going to have you take a shot at, so you can have quick reference as we go through today's lesson here. All right, so let's talk about the different forms here. Now, the different forms you have been introduced to a certain extent in the previous chapter. So we're going to look at them in greater detail in this lesson. And those two forms refer to what's called the standard form and the factored form. Now, the standard form is something you have seen quite often in the last chapter as well as this one. And remember that anytime you have an equation, okay, that has a letter x with an exponent 2 attached to it. Remember, I mentioned that a giveaway that what you have there is indeed a quadratic relation. Now, in standard form, okay, you notice there's a bunch of letters there, but the one letter that's very important is the letter C, okay? And what the C represents in a quadratic relation is the y-intercept. So if you were to draw this and you would get a parabola that either opens downwards or opens upwards, the C tells you where that parabola or curve touches the y-axis. So that's what the value for C will be. All right. And remember that in the previous chapter, you learned all those different types of factoring, the common factoring, the difference of squares, and factoring a trinomial using product and sum. Well, it was called factoring because what you did there was change it into what was called factored form. Now, in this chapter here, we're actually going to be using it after we factor it out. And what you have to know about the factored form is that the R and the S represent what are called the x-intercepts, or where the curve touches the x-axis. And most of our examples will either involve one x-intercept or two. Okay, so that's what you just have to know in terms of how what that's going to be. All right, and the x-intercepts, okay, they're also known as zeros because you're going to see that we'll be solving for what are called zeros because we're going to take the factored form and we're going to let y equals 0. All right. Now that you've seen the two forms over here, I just want you to take a quick glance before I proceed to the next screen over here. And I want you to take a look at what letters they have in common, i.e., what letters do they have the same. Okay, so you notice they have an X and a Y, okay, and they have one other letter that they also have the same. And guess what it is? Yep, you guessed it, it's the letter A. Now, you were introduced to the letter A back in chapter 6 when you're trying to figure out whether a parabola opens up or opens down. Well, guess what? It's the exact same thing for this one. Notice for the standard form, you have an A in front of the x squared, and you also have an A in front of a set of the brackets in the factored form. Now, the letter A for both forms mean exactly the same thing. So remember in chapter 6, you discovered when the A is positive, that told us that what you had was a parabola that opens upwards, okay? And that you had a minimum, which is the bottom or the bottom center of the parabola. And when the A is negative, okay, what you have there was a parabola that opens downwards, okay? And the top point or the peak was the maximum, all right? Now, I mentioned earlier, okay, to have your phones ready, okay, please take a snapshot of this particular screen, okay, and just have it as a reference as we go through the next set of examples, okay, because I want you just to see how this particular screen ties in to what we're going to do in the next screen, all right? So if you haven't taken a shot of it, take a shot of it now. Cheese. All right, so take a look at some questions over here, and again, have that camera shot ready so you can follow along in terms of how we can use that particular screen to answer the next set of questions here. All right, so it says, given the quadratic relation y equals x squared plus 8x plus 15. So question I here is, does this relation have a minimum or maximum value? Now, the way you approach this is to take a look at the equation and see how in the world we're going to figure that out using the different numbers or in the different letters from the standard form. Now, in order for us to look at the minimum or maximum value, okay, we have to first figure out whether the parabola opens up or opens downwards. And the way we do that is to look at the a value. Now, if you look at the a value, okay, notice there's something missing there. But remember, there is a number in front of that x squared, okay? And you probably remember it to be the number 1. Okay, so since a is equal to 1, we know that what we have here is an a that is positive. Now remember, when the a is positive, if you take a look at your camera shot there or your notes, okay, we have a parabola that opens upwards. Okay, so when the parabola opens upwards, what we'll have there is a minimum value. Okay, so just remember that again when you approach this. That's where you need to look in that equation. Notice we don't have a graph to work with here. Okay, so that's why it's important you understand the different letters when it comes to the standard form. Now it says, what is the y-intercept of this relation? So if you take a look at the standard form, remember that the c represents the y-intercept. Okay, so if you take a look at this equation, the c value, if you line it up, okay, is going to be the 15. So the y-intercept for this relation is going to be 15. All right. So notice all we've done here is to align the standard form. Okay, look at the different parts of it, and you can see how we can gather information simply just by looking at the equation. All right. Okay, so the next part, we now need to factor the trinomial here. And what we want to do here is to approach this using the product and sum method here. All right, so what we have here, again, remember the product, okay, is the number on its own. So that's going to be the plus 15. Okay, and the sum here is going to be the positive 8. So remember that when we're factoring a trinomial using the product and sum, we have to find two numbers such that when you multiply them, give you 15 in this case, and the same two numbers to give you 8 when you add them. Okay, so let's go through the brainstorming process here. So let's take a look at it here with using our whiteboard here. So what we want to do here is to find, again, two numbers such that we multiply them, give us 15, okay? And the same two numbers when we add them, okay, give us 8, all right? Now remember, when you're looking at every possibility, okay, what you have to do there is always start off with 1, okay? And all you have to do for this one, again, is to take the product of 15, okay, and then divide it by the number that you have there. So for example, 15 divided by 1, okay, that's going to give me 15. Okay, now 15 is an odd number. Okay, so 2 does not go into 15. Okay, so let's try 3. So 15 divided by 3 will give me 5. Okay, now again, 15 is an odd number, so we know 4 doesn't. Okay, now if we do 5 over here, 5 goes into 15. However, since we already have 5 recorded, okay, we're done looking at every possibility. Now, if you take a look at these two numbers, okay, notice we have 1 and 15 and 3 and 5. So again, I want you to take a look at each pair, the 1, 15 and 3, 5, and figure out which two numbers, when we put them together or add them together, give us 8. Well, by process of elimination here, well, 1 plus 15 gives me 16. Okay, so we know that our two numbers here are 3 and 5 there. All right, so going back to the original question here, our two numbers here will be 3 and 5 or 5 and 3. Again, the order doesn't matter. All right. So that's going to be our first bracket, and that's going to be our second bracket. All right. Now, like I said, in the previous chapter, when it came to factoring, we stopped there, okay, because we just learned this skill. This is where now it's an extension. So in the next part here for a little IV here, or 4, it says using the factor form from 3, determine the zeros. Now, when you're finding zeros, what you're going to do here, okay, is you're going to use the factored form, and you're going to set y to equal 0. So that's the very first step. All right. Now, pay very close attention to the next step here when we're solving for the zeros. Now, when we're solving for the zeros, all we're going to do here is we're going to break apart each bracket and then solve for the x by letting each bracket equal 0. So the first bracket here, the x plus 5, which I have there with the bracket the red bracket underneath it, we're going to take that x plus 5 and we're going to let it equal 0 like this. Okay. Now all we're going to do here is isolate the x by taking the positive 5. Okay. And then moving it to the other side, making it negative. Okay, and sure enough, that will give us our first 0, which in this case here will be -5. Okay, so that's going to be the first 0. So you're probably asking, well, what in the world is the second 0? Well, the second 0 is simply the other bracket. Okay, so we're going to take the x plus 3. We're going to let that equal 0. And then just like the previous question, in this case, we're going to isolate x by taking the 3, moving it to the other side and making a negative. Okay, and sure enough, notice that that gives us our second 0. Okay, so you can see here that after we factor it out, okay, all you have to do is break apart each bracket and let it equal 0, and then solve for the x simply by moving the number of the other side and changing the sign. Okay, just like we did in chapter 4 when we were solving equations. And that's exactly what we did in this example. All right. Okay, so moving forward, let's take a look at another one. So it says, given the quadratic relation y equals x squared, okay, plus 2x minus 8, okay, what we're going to do here is to do the exact same thing, is to analyze it, okay, and again, we're going to analyze it the exact same way here. Okay, so what we have here, again, is y equals x squared plus 2x minus 8. So in order for us to figure out whether something's a minimum or a maximum, we always have to look at the value for the a. And just like the previous question here, okay, notice that we have a value of a equals 1, which is positive. Okay, so that tells us we have a problem that opens up, and what we have there is a minimum. Okay, so that part is exactly the same as the previous one. Now remember, the y-intercept is the value for c, and remember, the c is always the number by itself. Now be careful with this one, because you notice if you look at the number, okay, you also had to take a look at the sign that's attached to it. So you notice that what we have here is a -8. So the y-intercept of this particular relation, okay, is going to be -8. Okay. Now for the next part, what we want to do here is to take that quadratic relation and then factor it out. Okay, so in this case over here, again, we're looking at the product and the sum. So remember, it's the product here is the number that's on its own, okay, meaning there's no letter attached to it. So in this case here, our product here is -8, okay, and our sum here is +2. All right. Now, again, we're gonna do this step by step for the people who need that extra step for us to solve this. Because remember that what we have here is a negative product, okay, and a positive sum. So what I want to do here is to go through the different combinations of numbers to determine what the two numbers will be here. All right. So let's go to our white screen here, okay, and take a look at our two numbers. So what we had to do here, again, was to look at a product of -8, okay, and a sum of +2 there, all right? Now, if you recall from the previous chapter, okay, whenever you have a negative product, okay, when you have a negative product, you'll always have one number that is positive and one number that's negative, always. Okay, so this one over here, we're going to start off with 1. So when I go -8 divided by 1, that's going to give me -8. Now, anytime you have a negative product, always look at the same two numbers, but simply just switch the signs. So we have 1 and -8, so we're also going to look at -1 and 8. Now, -8 is an even number, so let's take a look at 2. Okay, so what we have here is -8 divided by 2, which gives me -4, okay, which is going to be the same thing as, sorry, when we look at the swapping of the signs, that's also going to be -2 and 4, all right? Okay, now I'm just going to do this for demonstration over here. Okay, 4 also goes into 8. Okay, however, since we already have the 4 in the previous step, okay, we don't need to look at 4. So those are our 4 combinations here. Now, if you look at each combination of numbers separately, the 1 -8, the -1 8, 2 and -4, and -2 and 4, okay, take a look at each one and see which one, when you add them together or group them together, will give you +2. Well, let's look at the first one. Well, 1 minus 8 gives me -7. Okay, so that ain't it. -1 plus 8 gives me +7. Okay, so we know that ain't it either. Okay, 2 minus 4 is -2. All right, so notice by process of elimination, what we have here is -2 and 4. Just to double check, -2 plus 4 does give me positive 2 there. So those are indeed our two numbers there. All right. So let's go back to our problem here. So our two numbers, as we mentioned before, okay, are going to be positive 4 and negative 2, or negative 2 and positive 4. Again, the order doesn't really matter here. All right. So now that we have our two numbers, we're now going to do the exact same thing as the previous example. We're going to let y equal 0. So again, when you get to this step here, always make sure you replace the y there with 0. Now remember, the purpose of solving for zeros is to break apart each bracket and letting each bracket equal 0 and then solving for the x. So for the first 0 here, we have 0 equals x plus 4 here. So you're going to see that I'm going to take this positive 4, okay, move it to the other side, and then it becomes a negative. All right. So our second 0 will be the x minus 2 bracket. We're going to let that equal 0. Now for this one here, you're going to be taking the negative 2, okay, moving to the other side and then making it positive. So our two zeros here will be negative 4 and positive 2 respectively. All right. So you've seen the two examples. Now you've seen how to analyze a quadratic relation, determine whether you have minimum or maximum, okay, and figure out where the y-intercept is. And then the extension to it again is factoring it out. In this case here today, we looked at an example of revisiting the product and sum and then extending it from there. All right, let's move forward over here and take a look at a word problem. And in this case, we're dealing with a bridge here. So it says the curve formed by a roped bridge can be modeled by the relation y equals x squared minus 9x plus 18. Okay, x represents the horizontal or the distance across in meters, and y represents the height in meters. All right, so what we want to do here is to factor out the trinomial first. Okay, so you can see here what we're going to do here is to use product and sum. So you can see here the product here is 18, okay, and the sum here is negative 9. So what we want to do here is to find two numbers such that when we multiply them, give us positive 18, and when we group or add the two numbers together, give us negative 9. So let's go back to our whiteboard here. Okay, so again, what we have here, we're looking at a product of 18, okay, and a sum of negative 9 here. All right, so always start off with 1. Okay, so we have 18 divided by 1, which gives me 18. Now, 18 happens to be an even number, so we know 2 goes into it. So 18 divided by 2, that gives me 9. Okay, 18, 3 also goes into 18, so 18 divided by 3 is 6. Okay. Now, just to look at the next one here, 18 is an even number, but neither 4, so 4 doesn't go into 18. You can try 18 divided by 4 gives you a decimal. Okay, so 5 doesn't go 18, and we already have 6 accounted for. All right, so we have 3 combinations of numbers, so we need to see which pair of numbers, when we add them together or put them together, give us negative 9. Well, let's take a look. Okay, so we have 1 plus 18 gives me 19, so that ain't it. Okay, 2 plus 9 is 11, so that ain't it either. Now, 3 plus 6 gives me 9, positive 9. Now, if you recall, one of the rules I taught you in the previous chapter is that anytime you have a positive product, both of your numbers will have the same sign or integer. Okay, so 3 plus 6 does give us positive 9. But going back to the product, remember, as I said before, if you have a positive product, okay, the two numbers must have the same sign. Well, it can't be both positive, so our only possibility for the next one are two negatives. So let's check this out. So if I go negative 3 times negative 6, okay, it gives me positive 18. So that checks out. And also, what also checks out, negative 3 minus 6 also gives me negative 9. So guess what? Those are our two numbers here. All right, so let's go back to the problem here. And you can see what we have here are indeed the two numbers of negative 6, negative 3, or negative 3, negative 6. All right, so we factor that out. Now, it says using the factored form to determine the zeros. So we're going to take that form and we're going to replace y there with a 0. All right, and as you can see, our first 0 here is going to be 0 is equal to x minus 6. So we're going to take the negative 6, move the other side, and make that 6. And last but not least here, okay, we have second 0, which is going to be x minus 3. We're going to take the negative 3, okay, move it the other side, okay, and make it a positive 3 there. All right. And you can see now again how this relates back to what we did in the previous chapter and how it ties into this one. Now, this is the part I want to use a drawing. Okay, I don't like drawing, but it does help for this particular example here. All right, so we know it's a bridge. Okay, I just want you to factor in what a bridge will look like here. All right, and you can see by the little diagram on the right hand side there, we happen to have one of those suspending bridges, which happens to be a slight parabola that opens upwards here. So how does that relate to this question? Well, the next question is asking us a specific question. All right. Now, like I said, different people will probably forget this right away, but I'm going to use a drawing to help you understand what this problem is. Okay, so notice our two values there are 3 and 6. And now it's asking us for the horizontal distance of the bridge from one end to the other. So I just want to draw this out so you can understand what in the world the 6 and the 3 are. All right, so okay, so if we take a look at the drawing here, like I said, I'm going to draw this. So a bridge, like I mentioned before, okay, what we had there was a suspending bridge. So you would have a problem that opens downwards over here. So let's fix this because I want it to be accurate. Like I said, I'm very picky when it comes to drawing. So we have a bridge that's going to go this way. Okay, and what we have there, okay, when you're looking at the horizontal distance across, it's asking you for the distance across here. Now, our two numbers there were 3, okay, and 6. And you're probably wondering, what in the world are those two numbers when it comes to this? Well, if you think about the bridge over here, okay, what we would have here, okay, is again, sorry, I want to make it exactly the same as the diagram there. Okay, what we would have here is basically the start of the bridge that would be at 3, okay, and the end of the bridge here would be the 6 here. So it's asking us for the distance between this point over here and this point over here. Well, if you take a look at this over here, you notice that to go from 3 to 6, okay, it's going to be 3 meters. Okay, guess what? That's the answer to this question here. All right, another way you could look at it, okay, if we go back to the question for the people who chose to do it mathematically, okay, well, another way you could do it simply just to take the 6 and just subtract the 3 from it. Okay, so notice either way, okay, will help you understand the question. And the reason why I drew the drawing there, because a lot of people just wanted to know what the 3 and the 6 were. So I just wanted to make it clear what it was for this particular question. All right. Okay, so again, the horizontal distance or the distance between the 2 points there was 3 meters. And like I said, I presented to you in 2 different ways there. All right. So that wraps up this section over here. So again, continue working on the Chapter 8 review, and I'll see you in the next lesson.